At the core of our platform, there are a lot of data analysis algorithms and a set of neural network called Zorax, as well as a special system which interacts with the largest crypto exchanges. This system consists out of 5 main blocks. The first block is the information collection system. It is a system of robots which aggregates information from tens of billions of actions from the cryptocurrency market participants. The second block is the analysis system. Using the gathered data from the first block, the information is automatically systemized and transformed into factors on the basis of which the system will decide on the composition of coins. The third block is the neural network. This block is made up of the 5 neural networks which, on the basis of training, accumulates newly received information and creates forecasts for the most important metrics of cryptocurrencies. The fourth block is the test purchase module. The test purchase module executes a test purchase and a sale of each of the coins using a very small amount of funds from our special testing reserves. Then there is a fifth block called rebalancing module. Every month, the system makes a repeated analysis of all the coins based on the whole dataset collected during the month, containing long-term and mid-term factors, including the test purchase, and decides which coins will remain in the index, in which proportion, and which ones have to be removed or added. And now let's go and see how it actually works. What is Zorax? Currently, the perception of cryptocurrency market participants and spectators are shaped by a vast body of information across the web, social media, and news outlets. So how can one filter the information important from the less useful noise? How can the potential impact of information be evaluated? How can we use it to make a balanced decision? Cryptoindex team collected a large data set from CoinMarketCap and started to backtest it against the various stock markets models that had been developed earlier. However, very soon we realized that this approach works poorly for a number of reasons, and among the others is that crypto trading is decentralized and it is 24/7. The crypto trading has higher volatility of the crypto markets compared to stock market. The pattern of crypto market changes several times a year. There is no free float. The number of participants is growing exponentially, not in a linear fashion. New coins and additional issues of existing coins are accelerating capitalization of the market. As a response to this and many other reasons, Zorax was created in order to improve the reliability of our models. Zorax is based on 3 main principles. First, usage of raw data, direct data from exchanges, order books and trades, and raw sentiment data, Twitter, crypto media, Telegram, and other. Second, coin rating. Each coin has a calculated rating on the basis of several neural networks. 3. Rebalancing. The index is not static. Its composition is dependent on the rating of each coin, updated in accordance with changes in the rating of coins. Data obtained directly from the largest exchanges. This allows us to form a primary set of more than 100 factors which considers not only the movements of prices and volumes, but also the dynamics of exchanges themselves, for example, the transaction clusters. Zorax is a set of neural networks. Neural networks are a subset of machine learning methods, which is an emerging field of artificial intelligence. Other areas of machine learning include classical machine learning, reinforcement learning, ensemble learning. Each of those are used in certain conditions. Why neural networks are used for rebalancing? The best way to analyze all the data and all the extracted factors is to use neural networks, because the amount of data and work becomes too large for any other means of analysis. So after data collection, data pre-processing, and factor extraction, the following happens. First, the pre-processed trading data is split into batches of size between 32 and 128, where each day has a dimension of days between 30 and 180, and a dimension of a number of calculated factors. Then there is a neural network training. The neural network is built using TensorFlow. It makes time series of tensors as input and learns to predict a number of outputs in the future. More target outputs will be added to Zorax. After training, the neural network makes predictions on the test set, and the results of predictions are compared with the actual data. The error is calculated as the cross-entropy between the actual and the predicted outputs, and the accuracy function is an Argmax. The network does not learn from the test data for predictions. Then, TensorBoard generates visualizations for the neural network performance. The error is measured using cross-entropy. The mathematical definition says that cross-entropy is used to quantify the difference between true probability distributors. But in order to get a clearer data, let's look at an example. Now we can see the histograms showing the number of times when the accuracy was equal to a particular value between 0 and 1 on the x-axis. The graph have a time axis. It creates layers which visually appear to sit on the behind another. So the graphs that are at the forefront of the image represent a later time. As we move in the time and the neural network trains, the image appears to be moving toward us. The performance is becoming better if that movement, the layer shifts toward the left or toward 0 on the x-axis, which means that more and more time the predicted output is close to the real output and the distance between them is small. We can see that the position class shows the best results, blue. The return are predicted slightly less accurately, dark orange. And the trend predictions are less accurate, yet all through the improvement of the network is clearly seen on the diagrams. Here we can see the factors running in train position. Let us leave them to run and train. It is important to say that these graphs are one of the intermediate stages of Zorax. We made an interface that demonstrates the work of neural networks. Now we showed you one of the older neural networks that were developed by us, but just as an example of how Zorax works and trains. But we do not show the real production neural network because we want to keep the know-how and all the achievements of our team as intellectual property of Cryptoindex, which will be available only to the Cryptoindex holders. Thank you for watching.